Welcome to the second lecture in Programming 1, where we will introduce the programming language Python. Python is an extremely popular and powerful programming language that is relatively easy to learn because it is quite close to regular English. You can do a lot with a few lines of Python code. Furthermore, it has plenty of libraries for things like data analytics, machine learning, web development, and even games. And there are plenty of jobs for Python programmers today. Is it the perfect programming language for everything? No, but it's pretty darn good. So let's see what all the hype is about. Here are the objectives of this lesson. Firstly, we will introduce IDLE, which is short for Integrated Development Environment. This is the programming environment that comes included when you install Python and the one that we will be using throughout this module. Next, we will explain some of the components in Python, such as variables, statements, and comments, which together form programs. Finally, we will examine the usage of variables in Python, which is just a name that you give to some value. Variables are an indispensable part of all programming languages. Python is a general-purpose, high-level programming language with a comprehensive set of libraries. You can use Python for everything from developing desktop graphical user interface or GUI applications, websites and web applications, to data analytics, machine learning, and mathematical simulations. It was developed early 1990s by Guido van Rossum. Python is designed so that you can focus on the core functionality of the application rather than having to pay attention to the low-level details. So in Python, you can often do something using one statement that other lower-level programming languages like C++ or Java might require a dozen statements. The simple syntax rules of Python also often makes it easier for you to keep the code base readable, and so the application you create is easier to maintain and update. Python is really popular worldwide for a variety of programming tasks. Here are a few examples. It is ideal for scripting, which is the writing of short programs to perform administrative tasks. So if you have a directory full of music videos and you want to extract all the Taylor Swift songs about old boyfriends, you might be able to write a Python script for that. Spoiler alert, it's most of them. There are web frameworks such as Django or Zope that allow you to rapidly create professional websites using Python. You can quickly create things like web forms, embed media, query databases, and a whole host of other features. Python is also really useful for web scraping. With libraries like Selenium or Beautiful Soup, you can go through social media sites like Facebook, Twitter, and Instagram to do social media analytics. Or possibly you could crawl through a whole bunch of job portals to find the highest paying IT jobs within 10 minutes of your home. Incidentally, ICT is not the only school to teach programming using Python. Top-tier universities like NUS, Cambridge, Carnegie Mellon University, and MIT are also using Python as the introductory programming language for their students. So hey, looks like we're in pretty good company. For this course, we will be using the IDLE Integrated Development Environment, or IDE, for our Python coding. There's several reasons that we're using IDLE. So firstly, because it comes free with your Python installation, we know that every student has access to it. Secondly, while it is a no-frills development environment, it is powerful enough to use to develop commercial systems. And the fact that it is no-frills also helps to stop beginner students from developing bad habits, such as getting overly reliant on some commercial IDE's autocomplete feature. Also, it's free and we're cheap. Other IDEs exist, such as Notepad++, Sublime, Eclipse, etc. As you get more familiar with Python, you can explore other IDEs that may have features that you like. But for now, we are sticking with IDLE. You can refer to the Python installation guide in MEL to install the software. If you haven't already done so, pause this lesson and install Python before continuing. Now that you have installed Python successfully, let's do a simple program. The first thing you need to do is to launch IDLE. If you're on a Windows system, just click on the magnifying glass thingy on the toolbar at the bottom left of your screen and type in idle. Then select the program that pops up. When you do so, you should see a Python shell. Now, this is important. The Python shell is not where you should be writing your programs. It is where the outputs for your programs will appear. Instead, you should choose File, then New Window. Another window should pop up, which is the editor. And this is where your program code should be entered. Now, let's do a simple one-line Python program. Type the following exactly. Print, open bracket, inverted comma, welcome to ICT exclamation point, inverted comma, close bracket. Okay, next, save your program by choosing File, then Save. A dialog should pop up, right? And for now, select Desktop from the menu on the left. Then in the file namespace, type welcome.py, okay, without the inverted commas. Finally, run your program by choosing Run, followed by Run module. The Python shell should pop up and show the line, Welcome to ICT. If you've done all the steps correctly, congratulations, you are officially a Python programmer. As you get familiar with idle, you might want to increase your efficiency by learning some of its useful shortcuts. You can see what the shortcuts are when you select the various functionalities from the drop-down menus, as they are given to the right of each option. So for instance, you can use Ctrl-N to open a new editor window to start a new program. Ctrl-O allows you to open an existing file. Ctrl-S is a shortcut you should use often, as it saves your current file. And F5 runs the program. But perhaps the most important shortcut of all is Ctrl-Z, which undoes your last action. When you have done something stupid and messed up your program, sometimes the best solution is to hit Ctrl-Z a few times to undo your actions. Yep, takebacks are allowed in programming. There are plenty of other shortcuts, such as alternate 3 and 4 to comment and uncomment lines, or Control right square bracket and Control left square bracket to indent and dedent your lines. We will leave you to explore them on your own. Let us now talk about some of the components in Python. What do we mean by components? It's actually similar to components in a written language like English. The English written language is made up of different words, and when they are put together in various ways, following the rules of English, they convey different meanings. There's also punctuations like full stops, commas, and exclamation points. Similarly, Python is also made of these various components, including variables, reserved keywords, and operators. And when you put them all together in different ways, following the rules of Python, they translate to different programs. So let's see what kind of components are in Python. Identifiers are names defined by the programmer. They are used to store information in Python programs. If you want to store the age of someone, you can declare an identifier called age and assign a value to it. We also call these variables since you can change their values, meaning they vary. All identifier names in Python are case sensitive. This means that an uppercase letter B is different from lowercase letter b, so be careful when you're typing. There are some rules that you must follow when you create Python identifiers. They can only contain 3 types of characters: lowercase or uppercase letters, digits, and the underscore character. Furthermore, Python identifiers cannot begin with a digit. In addition to these strict rules, over the years, programmers have come up with some practical conventions for creating identifiers. Firstly, user-defined variables should begin with a lowercase letter. This is because names starting with uppercase letters are for classes, which is a concept that you will learn in programming too. Secondly, and this is very important, identifier names should be meaningful. So what we mean by that is, if the variable represents the age of a person, just call it age, don't call it A. Sure, it's a couple of keystrokes more, but doing so greatly improves the readability of the program and helps to reduce logical errors. Here are some examples of valid identifiers. They all follow the rules: only letters, numbers, or underscore, and not starting with a number. So yes, even a single underscore is a valid identifier. But while these are all valid, none of them are particularly good identifiers, since you can't really tell what they mean just by reading them. And now here are some invalid identifiers, meaning they will not work in a Python program. The first one is actually the literal number 99. The first character cannot be a number, and you aren't allowed to use any other special character other than underscore. So no plus, no ampersand, or that @ sign either. Finally, 4 isn't a valid identifier because it is a reserved keyword. Wait, what's this reserved keyword business? Well, there are certain words that the Python language has reserved as they have special meanings. There are actually 33 of them as listed here, and we will explore what most of these keywords mean over the coming weeks. Basically, out of all the possible identifiers, there are only these 33 that are not allowed to use. Anyway, idle will highlight them in a different color to show that they are reserved. Next, let's talk briefly about Python statements. Statements in Python are separated by a new line character, which is the invisible character you create when you hit the enter key in order to move to the next line. So this means that you cannot split a statement into multiple lines in Python by pressing the enter key. Instead, if the statement is too long, you can use a backslash to indicate that a statement is continued on the next line. You will see the use of backslash to split lines a lot in the slides in this module simply because slides have a limited width and we want to show you the entire statement on one slide. And then we have comments. Comments are only for the sake of the human being because Python completely ignores them. If you have a complicated set of code and you want to write down some information about it, use comments. In production level code, the use of comments is practically mandatory. This because such code is likely to have multiple authors, and it is crucial that programmers can more easily understand what other programmers were coding. At the very least, all production level code will have a description of what the program does, what updates were done in each version and when, and of course the programmer's name and contact information, usually an email, in case there are questions. Also, there will be various comments scattered throughout the code where necessary. In Python, for a single line comment, everything after the hash character is a comment that is ignored by Python. Such a comment in Python starts with the hash and extends to the end of the physical line. For a multi-line comment, enclose the comment inside a pair of triple quotes. So that's 3 inverted commas or double inverted commas, both work. Idle helpfully highlights your comments in a different color to differentiate them from the rest of the code. When should you use comments? So anytime you're writing code that seems a little complicated, add a comment to remind yourself or anyone else about what you are doing. Because if you revisit your code a week, a month, or a year from now, you will appreciate not having to figure out what your past self was doing from scratch. Trust me on this one. A value is just one of the fundamental things like a letter or a number that a program manipulates. Python programs deal in values. So a person's age is 47, a person's name is John, and so on. All values have a type, and the type tells us the properties of a value. If the type of the value is an integer, which just means whole number, you know that we can add to it, subtract from it, multiply it with another number, and so on. If it is a string, think of it as a sequence of characters, we know that we can print it, count how many letters are in it, and see if the letter X is in it, and so on. Python has several basic data types. The two numeric data types are int and float. Int stands for integer, which is a whole number and can be negative or positive or zero. Float stands for floating point value, which is basically a number with a decimal point. There is another type of data called a bool, which is short for Boolean value. That's just a fancy way to say that the value can be either true or false. Those are the only two possible values for a Boolean variable. Finally, str stands for string, which is a sequence of characters. In Python, a single character is actually a string containing one character. It is expressed as a sequence of characters inside either single quotes or double quotes. There are actually other basic types like complex, list, tuple, and set. But let's stick to these 4 basic types for now. So, how do you find out what is the type of a particular value? Python has an inbuilt function called type, which can tell you the type of a value. So take a look at this example. You can see that strings belong to the class str, integers belong to the class int, and float belongs to the class float. So what's this class business? The short answer is that a type is a class that Python has defined for you. but you can actually define your own classes. At this point though, just use the two terms interchangeably. Let's do a little hands-on activity. First, take a look at these code snippets and try to predict what is the output. Then, check your answers by typing these one by one into the Python shell. That's the first window that pops up when you first start idle. Take your time, and you can pause the lesson until you are done. Do you get them all right? If you don't understand how some of these results come about, make sure to ask your tutor during your practical session. Here are some more exercises to try. Once again, if you are puzzled about any of these results, ask your tutor to explain during your practical session. The last concept we will cover in this lesson is variables, which is a super important concept, so pay attention. A variable is a kind of storage box used to store values, so that these values can be used or altered later in the program. The whole point of programs is to take some inputs, do some processing, and then produce some output. In order to do anything with inputs, the computer must be able to store them and then potentially modify various values as the computation goes on. All of this storage is done using variables. A variable must have a name, which must be a valid Python identifier as we discussed earlier. Python variable names should be meaningful names that reflect the nature of the value stored and begin with the lowercase letter. Once you have stored a value in a variable, you can retrieve its contents using its name and also change the value of the variable. So how do variables work? Essentially, the variable names you give map to computer memory locations in random access memory or RAM. The computer will reserve this location of the memory to store the value that is assigned to that variable. So you can think of RAM as a whiteboard, where you can write values that can be read and modified. Consider this program that calculates a person's body mass index or BMI given his weight and height. Take a bit of time to figure out what the program is doing. You can pause this lesson. Now, what are the variables in this program? Remember that we said that every value has a type and variables store values. So how does Python know what is the type of a particular variable's value? The way Python works is that at the point when the variable is assigned a value, it determines the type of the variable. To assign a value to a variable, you use the assignment operator, which is an equal sign. So consider the following assignment statements. Name equals to Smith and NRIC equals to 6812388. When these variables are given these values, their type is also determined. So in this case, the string Smith is given a type str, and the integer 6812388 is given a type int. What actually happens when these Python statements are executed is that the sequence of characters Smith is stored in some memory location. This location is mapped to the variable name, and its type is determined to be string. Similarly, the value 6812388 is stored in another location that is mapped to the variable NRIC, and its type is set to int. The equal sign in these statements is called the assignment operator. It is used to assign a value to a variable. The format of an assignment statement is variable equals value. In this example, for the statement weight equals to 55, we say that the value 55 has been assigned to the variable weight, or just weight becomes 55. Note that the movement of data is from the right of the equals to the left. If there was a value in weight before, it will be overwritten by 55. A variable can only store one value at a time. Now, let's take a look at the last line of this program, which is BMI equals to weight divided by height times height. This statement works from right to left in that the expression to the right of the assignment operator is first computed, and then the resulting value is assigned to the variable BMI. Cool, huh? Let's jump a little bit ahead and introduce the print function, which allows you to see the value of a variable on screen. Take a look at this statement. Print BMI equals, comma, BMI. What happens is that the value associated with the variable BMI is retrieved and concatenated or joined to the string BMI equals. And the following output is displayed. BMI equals to, in this case, 19.03114. You can use a simple print statement to check what is the value of your variables as the program runs. We will end this lesson with another activity. So suppose 3 friends went out for lunch and decided to split the bill evenly. Ahmad ordered $12.20 worth of food. Brian ordered $9.50 worth. Cheryl ordered $11 worth. You are to write a program called splitbill.py to calculate and display how much each person had to pay. In this activity, you must first state the input, process, and output needed to solve the problem, and then write a Python program to solve this problem based on the input, process, and output you have identified. As usual, complete and submit your activity to your ICT Space Network folder. So that's your quick first introduction to Python. In this lesson, we talked a bit about the Python programming language and what it's used for. We discussed Python identifiers and reserved words, statements and comments. We also talked about variables and different data types. And finally, we explained how you can use print to display simple output. You can now proceed to attempt the exercises in exercise week 1 found on Mail. Thank you for your attention. 1 week down, lots more fun and exciting programming to go.